Hey everybody, this lesson is solving absolute value inequalities graphically. And don't forget, all your lessons can be found at Mrmathblog.com. And then this class is integrated math too, so make sure you click that link once you get there. And then I'm going to start including the answers to the odds at the end of the video right here. So our homework assignment, and then right after that we'll have our answers, okay? So here's our question. What are two ways to solve an absolute value inequality? Today we're going to do just one of them. We're going to graph them. So determine whether each of the integers from -5 to +5 is a solution of the inequality. And then just write yes or no for each number in the table right there. And then if the number is a solution, we're going to plot that point on the line. Okay, so here's number one. So the absolute value of x plus 2 is less than 5. So we're going to plug in all of these integers from -5 to +5 and see if it satisfies this when we plug it into this absolute value here and then add 2. Is it going to be less than 5? Okay, so is the absolute value of -5 plus 2 less than 5? Well, this is positive 5, and 5 plus 2 is 7. 7 is not less than 5, so the answer is no, and we don't graph that right there. So we'll do the same thing with this integer, -4. Is the absolute value of -4 plus 2? Well, that's 6, you guys, because the absolute value of -4 is 4. 4 plus 2 is 6. That's not less than 5. So let's try so we wrote no right there, so let's try the next integer, -3, okay? That's still not less than 5. This equals 5 right there, so it's not less than 5. But when we plug in -2 is a yes, because absolute value of -2 is +2, and then 2 plus 2 is 4. That's less than 5. So it said if it is a solution, then plot it on the number line. So there it is plotted right there, okay? Now I skipped -1, I noticed that, so but -1 is a yes, but let's mentally plug it in. The absolute value of -1 is 1, 1 plus 2 is 3, and that's less than 5. So I did plot it, but I didn't, for whatever reason, I didn't fill it in right there. I skipped it. So here's 0. The absolute value of 0 works. Absolute value of 1 works. The absolute value of 2 works, but then as soon as we get to 3, it doesn't work, and neither does 4, and neither does 5. Okay, so there's the answers right there. Those are the integers that'll satisfy this inequality right there, okay? Same directions. Here's number 2. We're going to plug in these integers right here and see which ones are greater than 5. So if we plug in the absolute value of -5, okay, we're going to plug them all in right there. And which ones are greater? This is +5. 5 plus 2, yeah, that's greater than 5. 4 plus 2, that's greater than 5. 3 plus 2, nope. This is no, this is no. No, no, no. And then finally, these two right here are yeses right there. So when we plot them, it's going to be these two on this side. That's these guys right here. And then also 4 worked and 5 worked. So we plotted 4 and 5 right there. All these other integers were no right there, okay? So state the solution of the inequality. The absolute value of x plus 2 equals 5, because we had less than 5, then we had greater than 5. Here it's equal to 5. And how does that relate to the solutions we found in numbers 1 and 2 in section A? Okay, well the solutions are, because the 3 plus 2 equals 5. So what number would get us 3 when we plugged it in here? X equals -3 or +3. So -3 or 3 works, and they're the only numbers that are not the solutions of the inequalities in numbers 1 and 2 right there, okay? Something like that. So if x is any real number and not just an integer, we graphed just the integers, graphed the solutions, okay? So here was in section A, this is number 1, this is number 2 right here. We got these graphs when they were integers, so we plotted the integers right here. Okay, so when it's all real numbers, including fractions and decimals right here, if I did, say, 2.5 right there, 2.5, the absolute value is 2.5 plus 2 is 4.5. That's less than 5. So when we're talking about all real numbers, we're going to have open circles on -3 to +3, and it's all of these numbers inside of here. So we can say this solution as -3 is less than x is less than +3 right there. And then this one would be x is less than -3, that's this way. Or when there's a split like this, you always got to say the word or x is greater than positive 3 right there. Okay, so can you see the relationship with when they were integers right here, and when they are not integers, then we use the arrows and it's included all of them right there. All right, so solve this inequality graphically. Okay, so what we're going to do is we're going to treat this as f of x, and we're going to treat 4 to be g of x right there. So f of x right here is this absolute value equation, and we learned how to graph these before, and so it goes opposite same. Remember, these graph a V-shaped graph, and this one's going up because it's positive. So f of x, we're going to make f of x this left side, and we're going to make g of x this right side. Whoops, I got company here, so that's my daughter. She's cooking dinner. She just came back from the store. Anyway, so remember, the vertex is opposite same, so it's going to be negative 3, 1. Okay, so it's a V shape, so we go to the left 3, up 1, and it makes this V shape right here. And then g of x is just a horizontal line, y equals 4. Okay, y equals 4 is this horizontal line going right there. All right, so there's that right there. And then we want to know, where is f of x greater than g of x? Where is this left side greater than this right side? So where does the V-shaped graph, where is it graphed above the red one right there? Well, it's a graphed above right there, and then over here on this side right here, can you see the absolute value is above the horizontal line on these two sides? So these are x answers, so x answers are left and right movement, so it's above when x is this way, so when it's to the left of negative 6, and the absolute value is above when it's to the right of 0 right there. So we'll say that the solution is x is less than negative 6, that's to the left, or x is greater than 0, that's to the right of 0. All right, let's try another one here. Okay, so opposite same. So here's f of x right here. This will be g of x. G of x equals 1. So that's easy. A horizontal line, here's g of x equals 1 right there. This is going to be a v, where this is opposite same. Okay, so positive 2, negative 3. So over 2, down 3, and then we're going to do a v going right here. Okay, all right, so we want to know where is the f of x, which is this blue stuff, less than g of x, the red stuff right there. Okay, here we go. Okay, so where is it less than? Where's the blue graph less than or below the red graph? When it's in between here, so when it's to the right of negative 2 and to the left of positive 6 right there. Okay, so between the x values of x equals negative 2 and positive 6. Okay, so here's one way to say x is greater than negative 2 and x is less than 6. There's a shorter way when it's graphed in between. We'll talk about that in just a minute right there. Okay, all right, so suppose the inequality in section D had greater than or equal to instead of just greater than. Okay, how is that going to change the solution? Okay, well, here's the solution when it was just greater than. It was to the left of negative 6 and to the right of 0. So all that does is it includes the endpoint. So instead of x is less than negative 6, it's x is less than or equal to negative 6. And here this is x is greater than or equal to 0. Okay, and if they're shooting, if the solution is shooting in opposite directions, then we use the word or. If it's not in opposite directions, then we can use the word and. Okay, so here, you guys, and what's another way to write this? So the solution was this purple stuff below that right there. So when it's in between two values right here, you can start with this number and say negative 2 is less than x is less than positive 6 right there. Okay, the other one here, when it shoots in opposite directions, you got to say them with the or statement right here. But when it's in between two numbers right here, then you can do it this shorter way right there. Okay, never do a shorter way when it's going in opposite directions. You have to use the word or. All right, one more, you guys. So, okay, this is going to be f of x. This is going to be g of x right here. And we want to know, where is this, we'll make this blue again. Where's the blue less than or below the red right here? Okay, so opposite same. So negative 1, negative 4. So to the left 1, down 4. Here's the v, and it's going to go like this. Okay, and then y equals negative 2 is going to be this guy right here. And we want to know, where is the v shape less than below the red shape right there, the horizontal line right there. Okay, so there it is right there. Where is this blue guy below the red guy? Right here. So we can say It's up between the intervals. X is greater than -3 and less than -1 right there. Okay, so the solution is we start with the smallest number, the number on the left, -3, less than or equal to X. We use this symbol right here, and then less than or equal to +1 right there. All right, you guys. All right, if you are in my class or our class at Bella Vista, that would be your homework assignment. And here's the answers to that right there. All right, you guys, and then hit pause if you need to. Take care.